Hi, and welcome to this presentation called Learnings from the Enterprise-level Kubernetes Transformation at Elkjøp Nordic. That's a mouthful, super enterprise title. Let's try to keep it a bit loose and informal as well. This will be a presentation about how Henry and myself moved the sales portal tools used by the sales clerks and the microservice platform over to Kubernetes. And who are we? My name is Fredrik Klingenberg, and you can reach me at the usual places, Twitter. I'm usually at my full name on Slack, obviously on LinkedIn as well. In addition, I'm a traffic and Linkerd ambassador. Basically means I try to help out in the community when they have somewhat similar problems to what Henry and I have been facing at Elkjøp, for example. I love to chat about the platforms and hear what you guys are building as well.
And I'm Henry Hagnäs. Right now, I'm actually a cloud solution architect at Microsoft. I'm a data center lead, which means I do a lot of different stuff around the whole ecosystem of data centers that Microsoft has. But this story actually is a year in the making because of obviously a year ago we couldn't present this, but we felt that this story was meant to be told. So this is from the time that I was the enterprise cloud architect at Elkjøp, and we will be talking about what happened back then. I know that Elkjøp has continued their journey with Kubernetes. They're very happy with it. The things that we're talking about has been in production now for 2 years, or 2 Black Fridays at least, which is how Elkjøp really counts their IT infrastructure. So we're going to be talking through this and let you know a little bit on how to actually build this kind of environment. This is the only corporate slide that we're going to be talking about, but just to set a context, Elkjøp Nordic is an electronics retailer, big box retailer, 400 stores all over the Nordics, 10,000 employees plus, over half of them are in the stores. And this is about modernization, about their IT infrastructure. So this is the only slide, but please be very careful, take some pictures, because there's going to be a quiz in the end about the numbers. Okay, not really, no. If you have been at an Elkjøp store about a year ago or before, you would have seen a screen like this when they were ringing up your order. This is ElGuide. It's a beloved tool that was used for a really long time. So I think its full age is something like 30, almost 40 years. It's evolved a long time. And the developers of that, which were external from Elkjøp, were actually really good. So they were very proactive and very good at bringing changes. So business would often go to them and say, like, I need this and this to happen. What can we do? And they would, of course, add it because they get paid for it. That meant that it actually bloated. So in the back, even though the interface for the salespeople looked relatively simple, but still very old-fashioned, and you really don't want to teach this to a millennial. No offense to millennials, they're actually maybe smart to avoid this kind of stuff. But there really needed to be a reboot. So what happened about 3-4 years ago was that a big reorganization of the IT systems was started. It was called Next Generation Retail. And it was not just about this tool. It was not just about microservices. Actually, part of the ElGuide backend was already modernized and was using microservices that were shared with the ecom platform and so on. So it was already modernizing it, but this interface needed to be changed. And all those bloaty things that didn't go into a point of sale system needed to be moved out. So that meant that suddenly the microservices needed to be more of them. They needed to be more reliable, more available. And at the same time, the new point of sale system needed a hosting platform, which also is Kubernetes. This talk will focus on the microservices. But note that this is the same pattern is used for the point of sale system, for the e-com platform that is being rolled out in the different countries right now, and more. So at Elkjøp and in retail, Black Week or Black Friday, now Black Weeks, is a really important time. There's like tens of percentages of the whole year's sales happen then. And it's a fixed time, like you really, you need to be ready then. So there's a deadline and you need to have your IT systems working by then, or you're going to lose actually billions. So that's one of the pressures. And then, of course, when you have variable traffic, like suddenly you have 10 times more traffic, you need to have a scalable platform. When I joined Elkjøp, they already had a microservice architecture. It had about 70 different microservices. They were designed in a really nice way. They were using modern patterns with Azure Web Apps, Azure API management, and Service Bus, and so on. But you can imagine that before Black Friday, being the operations guy, the kind of operations architect, meant that I had to go through all these services. I had to understand how will more customer traffic impact these and scale them up and hopefully then do that right. Of course, they can still be scaled in production because they are modern, but then I have to monitor and figure out that are they failing or not. This worked for a while, but during this next generation retail project, more and more microservices were written, and suddenly we have 200 of them. And 200 app service plans times 3 environments, this was a really expensive platform, actually. It was doing a very good job. App services are really nice, but it costed us about 3 million NOK per year. That's a lot of money for this. Like it really, like that hurt to see. So it was actually easy to convince people that I want to hire Fredrik. I want Fredrik to help me build a kick-ass enterprise platform, and that's what we did. So we replaced the app services with Kubernetes. And this looks easy, right? Like, yeah, we just lift the applications, and they were already in C#, so it was a little bit of upgrading from framework to .NET Core, stuff like that. But actually, when you start digging into it, app services give you a lot more than just a hosting platform. So actually, it looks a bit like this. You have a bunch of different things that you have to think about to build an enterprise platform that truly works. You have to think about ingress controllers. How do you operate it? How do you do disaster recovery? Identity. Metrics, graphs, do you need network security? Do you need alerting, scaling, operational models? All this stuff needed to be decided. So this talk is about the guiding principles that we used to choose the different components. We're going to talk about how we built this platform, how we built a team around it. We're going to tell about the transformation journey, like how did we actually move all these microservices over to Kubernetes from App Service. We'll sprinkle in some really nice experiences, some learnings from that, and then, of course, a little bit conclusion on what were the learnings, and so on. And then, of course, please feel free to ask questions afterwards. We really are happy to help. And with that, Fredrik, what did we do, and what did we use to decide?
Yeah, Henry and I started building the platform, and we went to the CNCF, that's the Cloud Native Computing Foundation, that is hosting Kubernetes and Prometheus and a lot of good tools. And we saw that they had this cloud native landscape, and we thought that, great, this will be pretty easy. And then you go and see this, and I'm sure you've seen it before. I'm sure you heard all the jokes. This is a lot of technology, a lot of good technology. But we quickly realized that trying to introduce all of them or hitting all of them would be a bad idea. Then again, if I would have let you alone, you would have implemented all of them, or at least one in each box. It's a different story. Yeah, we needed some guiding principles to help us choose the correct subset of these tools. that's where the principles come into play. This is not an exhaustive list, maybe the most important ones. First off, we wanted to embrace the aspect-oriented programming model and move as much as possible of the cross-cutting concerns over to the platform. One example of that could be mutual TLS. So instead of having the developers doing certificate rotation, signing from CA, and all that, with checklists and QAs and everything, they should just get it for free by just deploying their application onto the platform. Obviously, by embracing this model, you make it harder to do mistakes because you don't have to do it. You just deploy application and you get mutual TLS for free. We also wanted to kind of nudge the developers back on the correct path if they made mistakes, instead of having, again, QAs and wikis and all that stuff. The biggest cost in software is often maintenance. It's actually not development. We wanted to introduce tools, but if that meant that we could save maybe a week of development time, but get an additional year of maintenance time in terms of cost, then we're not that interested. Not something specifically to our project, but reducing complexity, obviously, is something we want to do as well. If introducing a tooling or a framework to handle mutual TLS, it's actually more difficult to handle than to just do the certificate rotation signing yourself, then it's probably not worth it. And ubiquitous language, we worked closely with the teams, and as we moved them over to the platform, there were a lot of terms that were thrown around and mixed together. Services, a really overloaded term in IT, obviously. You have microservices, SOA, and all that stuff. So for our sake, we wanted to be very clear on our viewpoint and what we mean when we say certain terms working with the different teams. Everything as code, so not just the infrastructure as code, but load testing as code, system configuration as code, and have that in source control. It obviously is a good principle to have. And minimize developer friction. Henry mentioned Black Week. It's not something that you can move around. It's set in time. Developer needed to provide a lot of functionality, and then just adding a whole new platform makes it even more difficult. They're not that interested in doing that. So documentation and working closely with the developers to make it a enjoyable experience and make a platform that they want to use instead of something that they're being forced to use, which is often the case. Moving on to the building and managing of the platform here. What begins as a very trivial infrastructure setup using Kubernetes can quickly get out of hand. When you begin to scale, you begin to add more people, so the platform team size increases. You have more clusters. So we had the clusters, like I mentioned, for the microservices, but we also have clusters for the tools used by the sales clerks in all of the stores. Add different environments, dev, test, and production, maybe some more. It becomes really challenging to move fast without stepping on each other's toes.
Yeah, so in the beginning of or after we built kind of the very, very basic base, we realized that we need also a team that is actually running this, because before this, the DevOps teams or developers were doing kind of a best effort thing about keeping the systems running, and app services are quite stable. But now this became business critical. Like many of the old services, they were back-end services that could be stopped for a while because a lot of them were message-based and so on. But now we're in the firing line. It's like absolutely stops sales if it doesn't work. So then you need to have a professional team working. Our parent company, Currys in the UK and Elkjøp, has a back office in Brno in the Czech Republic. And there were a lot of very, very good people there who had been really working hard to keep the old platform that Currys uses online, because they have a heavy monster of Java applications, and they were very good network and Linux admins. So we went there and we found the best ones, and we kind of gave them a new challenge, like, do you want to work on something new? And they were like, okay, a little bit. And then we actually gave them a lot of responsibility from the start. So they were part of this from the start. We gave them more responsibility than they had before, because before they got very much like just given tasks from above. Now they were part of the team. And that really forged a very good place. And they would write their own alerts. They would then, of course, be responsible for it. And if they get woken up by this, they can't really complain to us, because they should have made it better then. And you shouldn't forget that this is about engineering. So site reliability engineering is not just operations rebranded. So we actually gave these people out to the different teams that were doing something complicated. They would sit in their sprint meetings. They would help them make telemetry and scaling decisions and all that kind of nice stuff. And that really led to a very good collaboration and a team that felt ownership of the platform. So we felt very confident to leave this environment when we both moved on from Elkjøp. And it has really worked. So it's like last Black Friday, just last week, worked perfectly. No complaints as far as I know, and I tried to ask. So,
as we included the SRE team, we ran into some scaling issues. Suddenly, I was not the only one firing off those kubectl commands against the API server. There were more of me. And we had somewhat similar setup that you see depicted on your right-hand side there. And there are obviously multiple issues with this setup. You have racing conditions on all changes, issues with disaster recovery. We use the managed Kubernetes service called AKS, and when you create a new one in disaster recovery, maybe you have to recreate stuff, you get a new API server, you get a new etcd cluster, and suddenly you need to fire off all those kubectl YAML files again. Does not provide any tooling for QAs, so we were running into issues like, have you applied this to which environment? And the list goes just on and on. And it boils down to us missing a ledger or missing an audit trail here. A helpful methodology that we used was GitOps. And Henry and I used GitOps on managing our entire platform. We did not get around to use it for the applications and the teams running on the platform. However, I'm currently working for If, the insurance company in the Nordics, and there I have used it for the platform and all the applications. And what we're going to be showing is kind of what we did at Elkjøp, and then I'll show you how we extended it at If, so you can do everything GitOps, more or less. So GitOps is a operating model. It's a the short version is that you move from a kind of push model where you push changes to the API server, and then you flip it around and go to a pull-based model where you have a component inside of Kubernetes that is pulling in the changes instead. There is very much a sharp separation between the continuous integration and the continuous deployment with GitOps. So for the teams, you would rip out all the YAML that they had spread around, give them a repository where you add that YAML, and that's the repository being pulled in. There's a very sharp separation between the CI and CD. The CI is pretty much the same. So they do QA, load testing, static code analysis, what have you. Everything is the same. You push an image, and that's that for the CI. Whereas the CD changes a little bit. Like I mentioned, you have that external repo. There's a balancing act of where the infrastructure as code start and end, and where the configuration start and end. There's multiple ways of doing it, obviously, and we chose a model where the infrastructure as code was really small. It was a small bash script that I wrote, just firing off some Azure CLI commands, bootstrapping the cluster, installing the smallest amount of components possible to start bootstrapping GitOps, and then start pulling in everything else. We used Flux to manage GitOps. So that's the component inside of Kubernetes that is pulling in those changes. You can use Argo CD. I think it's something called Open GitOps as well. You don't have to use Flux, but Flux worked fine for us. We used Flux version 1 at Elkjøp because version 2 wasn't finished yet. But at IF, I'm using version 2. And I highly recommend version 2 if you can use that one. So now you had all of those YAML being pulled in, but how do you manage secrets? You want to keep your entire system configuration, right? Not only the deployments, but also maybe some connection strings. And for that one, we used a tool called Sealed Secret from Bitnami. And the elevator pitch is that you create a YAML for a Kubernetes secret, use a public key and some tooling that creates a sealed secret. You installed in your cluster a sealed secret operator that has the private key. Once it sees that sealed secret coming by, does the decryption, and you have a regular Kubernetes secret again. And then, how do you manage small changes in your environment? Let's say you have a different connection string. You have some different secrets in dev versus test versus production, etc. And there we used Customize. I'm turning into a big Customize fan. I think it's a really good tool. Again, the elevator page, you have the YAML, Kubernetes YAML, Customize. You can then match for certain parts of that YAML and do overlays, so you can change certain parts of it. And then you can build upon that in a cascading manner, creating as complex or as easy as you like. With GitOps, the setup was much better. So now the platform admins would, instead of doing all of those apply commands to the API server, they would check into that repo. And now Git manages the race conditions, obviously. You have a nice ledger. You can see who did what and when. Everything is good. And then Flux is pulling in those changes on a regular basis and running in this reconciliation loop as well. A nice benefit here is that you can actually remove the access altogether. You don't have to have the admins touch the API server at all. What we do at IF is that they get access to read some logs and do changes there, but everything else has to go through Git. Even though some would get access and change stuff with the API server, since the Flux is running in that reconciliation loop, it would just overwrite it and turn it back to what's ever in the Git repo. So now you're certain that what you see in that Git repo is what you have in Kubernetes as well. This is the bootstrapping part, the small shell script that I wrote. Very, very easy. At IF, we just have it running in Azure DevOps, but you can run it wherever. Installs the sealed secret controller, installs necessary component on Flux, and then start bootstrapping. It creates this Git repository CRD, which is then defining, okay, which repo from which branch should I start pulling in all those changes. And then you have a customized CRD that's actually doing the applying, and we'll come back to why that is a good idea. The platform components repo consists of this. You have Grafana, Prometheus, the usual suspects, but what's nice here is that you can have additional Git repositories synchronization. Here you see it syncing in from a systems repo. So this is how we do it at IF. If you want to introduce some platform technology, you add it to the platform components. If you want to introduce a separate team, you add it to the system repository. And here we have the system repository. start pulling in, and we give the different teams a repo that we manage, and they can add all the YAML that they want here. A nice benefit is that you see the customization is actually running as a cluster role. It's running as a SA, obviously, and the SA has a connection to that cluster role. And that cluster role is something that we in the platform team can manage. So you can say that this team should not be able to create services of type load balancer, for example. Even though if they drop that YAML into that repo, it would just stop. You don't have access. And this gives you peace of mind and flexibility you need. Disaster recovery. I was doing an upgrade of Kubernetes at Elkjøp, and as I mentioned, we're using the managed Kubernetes service from Azure called AKS. Should be pretty routine. Just click the drop-down button, new version, and click go. And I ended spending the entire night with Microsoft support trying to figure things out because it wasn't working. We lost everything. The bug is now fixed. It's not that important what it was, but this critical story kind of nudges us in the right direction to start treating the platform as being immutable. So instead of doing very large, complicated updates, which is updating the API server and the nodes, you would instead take it down and change the script, change the YAML, whatever you want, and then bring it up again. And there you get the disaster recovery training for free. And that's something that we learned from this one. The first training session, it's not a good idea to have that as the first live disaster.
Nope.
And at if, we're actually able to bring up everything in about 20 minutes. And the reason for those 20 minutes is that you're waiting for the provisioning of the nodes, and you're waiting for pulling down the images, and everything else is in Git. Can we just have a super short, quick show of hands? Who is using a service mesh with Kubernetes? And who did the white papers and deep dive analysis of the different service meshes before introducing it? Good. That went to 0. So yeah, the next point, service mesh, really, do we need that? Kubernetes has a lot of moving parts. Isn't that complicated enough?
And this was actually one of the first big conflicts or heavy discussions we had, because I felt that service mesh really seems overkill. Like, we trust the apps running, like why can't we just run them in one big happy cluster? But Fredrik convinced me that this is not going to be a problem, and it's going to solve some problems, and it did actually.
Yeah, so Henry mentioned that the previous microservice platform was with Azure App Services, and they are really good. You get encryption when they're calling each other for free. You get a lot of insights to CPU memory and network and everything of that. But you don't get that with Kubernetes. Now the application is running in the same network, they're communicating with each other unencrypted, and you're missing some of that insight that you get from Azure App Services. So those were the two problems that we wanted to solve. And we wanted to solve it in this aspect-oriented way. We didn't want to have even more burden on the developers. We looked at the usual suspects. So you have HashiCorp console, you have Mesh, you have Istio, and we ended up choosing Linkerd. Linkerd was very much aligned with the principles, like solve one thing, solve it well. It embraced the service mesh interface when it came out. It's a little bit question now where that service mesh interface is going. And we saw that they have really good day 2 operations, documentation, and community. Linkerd is also the fastest one. I doubt that Istio would have been a problem performance-wise, but we take all the performance gains that we can get. A lot of cool things with service meshes, but the one most important thing and the biggest benefit that we got was the metrics. A little bit different on service meshes maybe, but with Linkerd, it's injecting a small proxy in front of your applications. It's redirecting traffic through that proxy, and that proxy is emitting Prometheus metrics. So again, just by deploying your application, you get all those metrics for free. And that turned also be to one of the main sources for Grafana dashboards.
Yeah, the kind of main benefit of this ended up being that this, as an operations person, you probably have heard that developers blame the network, the operations guys blame the code, and this becomes a big kind of conflict and discussion before you actually get to the actual troubleshooting. And with Linkerd, that discussion was really, really short. We are right, you are wrong, and then we could move on. All right, of course we had sometimes issues too, but we actually caught them really quickly, and we can see that what is wrong, what is right, and have a very good conversation. And this was useful, especially when the ecom platform team was completely separate from us, but they were using our services a lot. And during development, it was a bit unstable, their code. So this was very useful. And in fact, the whole metrics versus logs discussion ended up being one of the key things that we discussed a lot, and what we brought as a learning and what we want to share with you guys today is exactly that the metrics versus logs discussion is very interesting. Because Elkjøp had already really good logging. When you do transactions with money and so on, you really want to have very good logs on exactly what happened, who did what, so you can prove that this was fraudulent or this was wrong and so on. So all microservices logged almost every packet that went through. That meant that the people who were reading those logs thought that this is amazing, we have so good insights into this, why would we need metrics? And that's what we showed them, that logs and metrics are different things. Like logs are important, of course, but metrics are also. Traces are kind of a world in between, and we did use tracing too. We're not going to go into those details today because it gets complicated. But tracing is also good if you can manage it. They're all really useful. So for context, logs are text-based, obviously. They're about events. That means that you don't see non-events. It's hard to know what was the right amount of logging at a certain time. You have to be quite good at writing queries for logging engines if you want to have things. And logs often look different from application to application. Like as an operations person jumping into a new system, how will you know if this warning actually is a warning or not? And of course, logs use a lot of space. If you're logging everything, it's really expensive. And then for a while, we were even logging the kind of service mesh health checks, and it got really expensive. So no, let's go to metrics. No logs were turned off, but we used a lot of metrics for the operations part. Because they are time series data, it's really easy to compress. You can see the non-events. You can see that traffic is going down even though it should go up. You can correlate different services. What happened when this went up and this went down? Why is that? It's easy to compress. It takes no time at all, no space at all, so it doesn't cost that much. And the pattern recognition part is really easy. Like if you do graphs, it's really easy for the human eye and brain to just understand that this is what happened. CPU went up, memory went down, latency went up. It's easy to think about it. On top of it, you can write queries. The queries we'd use for automation, for alerting, and so on. So it's really a very good way to understand your environment. Traces, of course, are really good for troubleshooting and so on. And the problem with logs is that you get this last, you basically start from the end of the story. You see that there's an exception, something crashed, something went wrong. And in a simple application, that's going to be really useful. But the database is not connecting. I should check the database. But when you have a really distributed and complicated application, this is the end result of a long chain of things that happened. The metrics, they look like this. They are CPU, their latency, and so on. But you actually can instrument your application to get much, much more information. And that's kind of what you start using when you troubleshoot using metrics. So here you can see all these graphs are on the same time frame. So you can see down that the success rate percentage goes down and drops like a cliff. And that might be the moment that the log starts writing exception, exception, exception. But if you look at the logs, the metrics, you can see that CPU usage went up a long time before the success rate went down. Latency went up before it started failing. So that means that there was something that started to go wrong. And this is the clue that you need to solve problems really quickly. If you start from the logs, of course you're going to find this error sooner or later, but you're going to end up having trouble and you're going to restart the service, you're going to have it crash again, and until you kind of find that murder mystery. Here it's much easier. So learning how to use metrics and understanding how the applications work in a microservice environment is really important. The traces can look like this, and they're really, really useful. You can pinpoint very quickly where the issue is. So I do also recommend tracing, but like I said, we're not going to go into the details. We promised to tell you a little bit about how the actual applications got transformed, because that's also, of course, the interesting part. Like I mentioned, 200 microservices. Some of them were still on .NET Framework, others were already on .NET Core, or what's now called just .NET. They were being developed in real time, basically. There's all the time, some of them were being changed. They were all the time running, and we couldn't have downtime to test and so on. So what we did was that the teams, we brought in the first few developers. They would help us figure out how to do the .NET conversion, what is needed to upgrade in terms of packages and libraries. Then they created a kind of template script that created the deploy files, the Docker file, and a new CI/CD pipeline that would push to the Kubernetes cluster. And then we would write documentation together on how they should add metrics and other Kubernetes-specific things like health endpoints and so on. Then they would do the testing in dev and test. And then, of course, at the end, when everything is working, you deploy into production, and the pipeline would actually switch it over in the API management to push against that the API management would point at the Kubernetes cluster instead. We would verify functionality, and then later, of course, remove the app services, but they would be in place there so that we can move over if something happened. So they were running in parallel. And then the developers would update the documentation, what did they learn, and go back to the beginning and maybe teach some new developers this. So by the end, we had really good documentation on how to upgrade our type of applications into our type of environment. And these were relatively standardized, so 200 microservices were transformed in just a matter of months, actually. And it didn't take many hours per application by the end that the documentation was really good. And then it means that we start to have a bunch of microservices in production. And how do we operate that then?
That's a large task. Let's move into the alerting part of operation, at least. This is a very high-level topology overview over our metric setup. We use the Prometheus operator to create Prometheuses, alert managers, and also have those alerting rules as code. We would have the different teams drop in some YAML with those alerting rules, and the Prometheus operator could pick it up and automatically configure Prometheuses to fire off those alerts. Prometheus also was one of those aspect-oriented way that we can just tell the developers to add some labels and also name the endpoints according to a convention, and then Prometheus goes just flying by and start scraping those endpoints. Not surprisingly, Grafana with Prometheus, a lot of people are using that one. So did we, and we created dashboards that were together with the development, with the developers, to show them the things that they were interested in seeing. Prometheus will fire off those alerting rules to Alert Manager, and what we saw was that Alerting Manager has this native integration to Opsgenie, and we're going to be discussing Opsgenie a little bit more a bit later. We used Thanos, really cool project, worked well. It helps with running Prometheus in high availability, long-term storage, and also querying across multiple Prometheuses. You can do that. I'm not going to dive into super details here, but Thanos is able to take 2 hours of blocks. So every 2 hours, it takes the blocks from the disk that Prometheus is using and shipping it off to long-term storage, such as Azure Blob. So in theory, we could set up graphs in Grafana showing the last 4 black weeks, how the trends were done. That would be difficult with the disks, obviously. This is an example of alerting rule as code. This one creates a separate alarm per backend, per code in the 500 range. And the really nice thing about these alerting rules is that they are generic. Again, moving things over to the platform, we would have this baseline of alerting rules that will automatically pick up the applications, because a lot of the metrics is emitted from Linkerd or from our Ingress controller. Just by deploying their application, you will automatically see all of the 500 range errors from the applications. And they will also fire off individual alarms per application as well.
And that's actually something that also improved the quality of the code, because we actually found out that the code was, in certain cases, retrying things in the background without telling anyone. So it was slow, but it worked. When we put this alerting rule on, we would actually see that, hey, this endpoint is having 5–10% error rate, which is terrible, but it was hidden away because it was running like this. And of course, that caught a problem, a quality issue that could have later led to a real outage.
My experience working on different teams is that escalation rules has been somewhat synonyms with wiki pages and best guesses. Maybe it's just me and the project I'm working on. Additionally, there's always been missing a repository somewhere where you can actually see, okay, what kind of alerts, how many alerts from different applications has there been, so they can try to up the game on reliability and create more reliable systems. And the logo on the right-hand side there is Opsgenie. You don't have to use Opsgenie. There are other tools that does the job as well. But accidentally, that was introduced during the time that Henry and I was finalizing the platform as a part of another project. And with this Opsgenie, you can configure escalation paths. So, for example, I could get the first alarm if I'm not answering within the first 10 minutes. And Opsgenie would actually call you with this robot talking to you. If I'm not answering, it will escalate, maybe call Henry, and then open up. And certainly, you will not only just get the errors or the alerts, but you will get it to the correct people.
And we also connected it to teams so that dev and test environments also got alerts, but of course no one needs to wake up to those. But in the morning, developers would be able to check the Teams channel and see, like, oops, my code is not running so well in test. Let's fix it before we go into production.
Yeah, and Opsgenie can also have this plan on who's on call, and yeah, a lot of cool functionality there. We didn't get around to it, but you can have these external viewpoints, a lot of viewpoints to upstream as well. So we were thinking about introducing kind of a status page, the similar ones that you see on GitHub status, that you can have one internal, one external. So that you can see from a very high level, are the API healthy? APIs, for example. Policy as code. I'm not going to dive into that one in great detail, but again, something as part of the aspect-oriented way and something we wanted to have using those guardrails over wikis. Super simple example, we had more elaborate policies as well, but we wanted to have all pods specifying CPU and memory request limits. And the open policy agent would just stop the applications from being deployed if that's not the case.
And we had this principle of choosing technology that only solves problems. So Helm was an example of a product that is really popular, but it didn't fit the way we worked, so we didn't use it. And that's really important, that choose technology that solves something for you.
We had Black Week coming up. As Henry mentioned, that's a week with very high traffic compared to the other weeks. We wanted to ride that wave without any issues, and we wanted to have that automatic scaling, something that Henry mentioned was missing before. We wanted to scale it up when there was big traffic and scale it down when there was small traffic to save money. And it could be like throwing a rock in a pond. If you're throwing a big rock, being big traffic, the pond just swallow it perfectly as it would for a very small rock as well. There are built-in scaling in Kubernetes. It's CPU and memory that can be used to scale up that horizontal pod autoscaler. It's not enough. You can imagine having those scaling dependencies. Let's say that you have application A receiving traffic and then doing internal calls to application B. If you have scaling on application A but not on B, you're going to run into issues. We want to be proactive with those scaling as well. Let's say that you have messages in the queue. CPU and memory, again, not helping you there. You want to scale it up when there are a lot of messages in those queues. We introduced some additional tooling to help us with this. One being KEDA, stands for Kubernetes Event-Driven Autoscaling. Again, the elevator pitch, it provides a lot of sources that can scale out that horizontal pod autoscaler in addition to CPU and memory, of course. Prometheus, another tool that we used, is able to get the metrics from Azure. So for the Azure Service Bus that was used quite heavily, Prometheus will get those metrics and provide it as Prometheus metrics, which then KEDA can use as the source for that horizontal pod autoscaler. And we also have different node pools. We would have one node pool that was static and used priority classes so that that one would be able to run the most critical component that we had in our cluster. So if everything went bad, it's actually able to run those as well. And then we'll have one that scales out. And that's also why it was so important to have those CPU request and limits, as I mentioned on the previous slides. You want to test your scaling as well. Just don't take it for to be good from the get-go. A tooling that we use that helped us to test quite rapidly was K6. Again, I'm sure there are other tools that does the job as well. We happen to like K6. It did the job. Makes it possible to have those low tests as code, check it in, all that good stuff. You can quite easily run it locally to test that your script is correct. And then just adding a parameter, you upload it to the infrastructure of K6, and you can simulate massive amount of traffic to see where those bottlenecks and what your services, how your services are providing. A cool extra feature, in addition to a lot of other things, is that K6 can fail based on checks. So in your scripts, you could have like the response time needs to be less than this. And then you will catch those applications that are slowly going more and more bad and yeah, using a lot of time.
And load testing really helped us in many ways. Like I'm sure everyone who's done production stuff knows that knowing how your system works is important. And nothing was more clear to us than when we were trying to go first, have the first country go online with the new point of sale system. So we're weeks away from launching in Denmark, and we figure let's do some load testing. Of course, we should test a little bit. It's going to be fine. We're going to roll it out slowly, so we're not going to have issues. We run a load test, and everything looks really good until it falls off a cliff. Completely stops working. Okay, scaling went wrong. Let's scale it up. It's going to be fine. Do it the same, and it actually fails even faster. More scale goes down faster. And long story short, we figured out that we are hitting a limit that's called the source network address translation. This is something that if you're doing outbound calls from a cluster, you really have to follow, because the load balancer needs to remember how to return the traffic from where it went. And there's a limit on how many of those outbound calls you can do, which is actually lower in Kubernetes than on a virtual machine or your laptop. So developer testing doesn't even catch this, and you don't catch this until you have a very significant amount of traffic, because these connections will reset by itself. So it will not fail hard enough for you to notice. So there's a silent failure, and even when you start hitting the limit, it's just like a few percentages of error. So the API starts to work just a little bit less perfectly, and until you actually have issues. And it's a code quality thing, like you have to reuse the connections and so on. You should read up on it, and you should have metrics on how to catch it. So we built these kinds of dashboards that would show us that under load testing, TCP connections goes up, and that's a sign that your code is not good, and you should fix it. Same is that you should have a warning that if these connections keep growing towards the limit, catch it before it's too late. And otherwise, this is going to be a silent error, and we did see this, in fact, not just in this application, but others when we started digging, and that was a good catch. And that actually is pretty much on time and end of our story. The Kubernetes clusters are working. They're working really fine. We did a lot of cost savings actually when we did this. So I mentioned 3 million NOK per year. The current platform is costing about 1 million, which still sounds a lot, but percentage-wise we saved a lot, and it is creating a lot of value. We think we could have optimized it further, but this was good enough when we went. It was pretty much a nice mic drop on the way out that, look at this, we saved a lot of money. Operational improvements were amazing. We would see the problems in the same dashboard. We would have the alerting. We would have the automatic scaling and also manual scaling, of course, which is much easier than going and clicking in a portal. Performance improved, partially because we had better insights into how the code worked, thanks to the metrics. But also when you have big nodes, they have more I/O, they have more capacity, and the applications sit closer to each other, which means that they actually perform better. So we got a lot of performance benefits there. Quality improvements, I mentioned the retries of the error 500s. We could fix those because we could see it. When we did the .NET Core conversion, we also got some performance, and we of course upgraded the latest and best practices in the teams to do it, so we actually improved a lot there too. So in conclusion, the metrics are really important. Like they really drove the kind of improvements that we did. We really got a lot of value out of that. And of course, the automation is really, really important, and that should not even need to be written, but we want to mention it too, like please automate everything, alerting everything, because otherwise you are not going to remember what you did, and you're going to be in a strange state where when you have to do some big changes. And with that, we thank you for your attention. It is late. It is Friday. We really appreciate that you came here and listened to us and you chose us. And if you have any questions now or later, just please reach out and we are very, very happy to help and answer. Thank you.
So I have a question. So early on you mentioned like one of the principles when doing this migration was to sort of apply the ubiquitous language to your services. And I guess like on first hand that's going to be like service names, maybe even service URLs. But did you apply that sort of deeper down the stack as well to the infrastructure, to service bus namespaces, to other parts of the infrastructure layer?
There was quite a lot of standardization on names already when it comes to like the naming standards. But the important part was this kind of like using the same terms for the same things, so that one team would call their application a microservice, other ones would call it something else, and then it became every time they came with a question, you had to first ask them, okay, do you mean this or do you mean that? So that's kind of the big benefit of having a common language.
Yeah. Did you sort of, like, ubiquitous language in itself is sort of a DDD term. Did you use sort of other DDD practices to sort of shape your infrastructure, to shape naming, to shape sort of how you think about services?
To be honest, we tried a lot around that, but we got a bit of pushback. It became a little bit of like, hey, infra guys, don't come in and tell us what to do. But we did improve a little bit on that also. So it was, you have to give small improvements step by step, and then it does get you further.
And so last question. So you mentioned you didn't really apply the GitOps strategy to application teams, only the infrastructure. Do you later have some sort of experience using GitOps from a dev team perspective?
Yeah, that's what we did or we are doing at If, and it's working really good.
Yeah, you're happy with it generally?
Yeah. So far, so good. Really beneficial to be able to change that system configuration without having to run your CI and create a new image, right? You sometimes want to change the configuration. Let's say more replicas here and there. That's totally separate from the application running. And you would have that repo for your system, and by system I mean all of the applications for a team. So you can configure now the delta between A and B needs to be this, and now we need to add some labels here. And yeah, powerful.
Okay, thank you.
Yes?
It seems like you have been running in a cloud service. What would you add or take away if you had to run it on-premise? And would you at all recommend running Kubernetes on-premise?
No. Yes, we used cloud, and Kubernetes really works best in cloud, in my opinion. There's so much else to go around to work around that. It has improved. So you have providers like VMware and OpenShift, and also Microsoft has this AKS HCI, which is a distribution that you can install, and it will take care of the etcd and other stuff. But you still end up operating a lot of stuff that is not easy, and the failure modes are very unknown. And so when you give it over the responsibility to the cloud vendor, you get a lot for free.
May I ask, you had as a starting point a set of microservices running as app services, and what was the main reason for justifying the transition to Kubernetes? Was it the number of services, or what is the boundary that you would recommend that step in, or just staying with auto-scaling of these services?
This is a very good question, and we thought a lot before that, and I've gone further in that thinking while I'm at Microsoft. And I would say that you really should think about it, because Kubernetes is complicated. At Elkjøp, the whole scale of amounts of microservices and the operational overhead of understanding all of those that became big, and the price got out of hand, so we would have had to do changes anyway in some way, maybe pack them tighter in app services or something like that. So then it made sense to start looking at the options, and then it really did make sense to go into Kubernetes. And that's kind of what I've learned since also, that if you have, what you do need is a good team, a team that wants to learn this and wants to operate it, because this is a little bit more hands-on than app services. So sometimes it's worth paying extra, even if you have a lot of app services. But in general, if you have a good team, you have the motivation, and you have the big scale, then I would recommend Kubernetes.
Now there is also additional products on the kind of path to full-blown Kubernetes. So we just have a few applications. You can use container apps, for example.
Yep.
Something that just came.
So
It's not like from Azure App Services over to only Kubernetes. We have some steps in the middle as well.
Yeah, that's actually just a few weeks ago, Microsoft launched this container apps, which actually would have been interesting if we would have had that available 3 years ago, because then you package in the right way your application and you give it to Microsoft, and Microsoft will then scale it according to the rules that you give it. So that, and you can actually take back that Kubernetes cluster if you later need more control. So it's an interesting concept, and I look forward to seeing it in action. But right now it's only available in a couple of data centers.
Cool, thank you.
Thank you, everyone.